Hey everyone, today I want to talk about binomial theorem and Pascal's triangle. So what is the binomial theorem and what is Pascal's triangle? And why does he have a triangle? How come I don't have a triangle? The Titan triangle. It's a nice ring to it. Binomial theorem is a way we can expand binomials, meaning multiply. So when we talk about multiplying polynomials or binomials in this instance, we're really using the area model for when we have a 2 by 2, a 3 by 3. We could also use it by a 4 by 4, but I would never do that because that just seems way too intense. Now, when we talk about expanding, that again is the multiplication aspect of it. Now, this video and both of these things do not apply to when we have binomials being multiplied together that are different. So my first case here is, let's say I had 2x minus 1 times 3x plus 4. I could certainly multiply these by doing the area model. I could FOIL it, or whatever we wanted to do. It is distributive property. This does not apply to this theorem or Pascal's triangle. What we're really talking about is if I were just to take one of these things, 2x minus 1, and raise it to a higher power. 3, 4, 5, whatever, right? Now a 2, we could certainly do it for a 2 as well, but really this is going to be applicable for things that are higher, 3 or higher in terms of the exponent, okay? So here's Pascal's triangle. Now I know it looks like a lot. It's actually rather simple and pretty intuitive once you take a look at it. So what's happening here is that we've got levels. I can't put my hand behind it because it's not opaque, right? So number 1 at the top, that just implies that we only have one value and it doesn't have a variable behind it. The second level here with 1 and 1 right next to it implies linear functions. So when we have x plus something, x minus something, something like that. At level 3 is what we're really talking about. So I'm going to try to get this arrow right. Take a look at that. 1, 2, and 1. Okay, that is what we call level 2. I know it looks like level 3. It's actually level 2 because level 0 is the first one. Now level 2 means it's the exponent of 2, meaning the highest exponent of 2 is where we're doing or where we're looking for this particular expansion. So what's really happening here? Let's say I had x minus 1 squared. Well, x minus 1 squared, when I expand this binomial, remember binomial just means 2 terms, right? Because like bi is in bicycle. So when I expand this, the first term I'm going to end up with has a coefficient of 1. The second term, or the middle term, will have a coefficient of 2 normally. And then the third term will have a coefficient of 1. So what does that really mean? Well, that just really means that Pascal's triangle is an aid. It's to help us understand what the coefficients are of higher powers in binomial expansion. So let's get right into it. I put a binomial theorem and Pascal's triangle on the side here so we can work out problems together. Example 1 is expand the binomial x plus 5 to the third power. Now, I want to make sure we get this right. I certainly could do x plus 5 times x plus 5 times x plus 5, but that's a nightmare because what's going to happen is you're going to make a mistake, and what do I FOIL first? What do I put in the area model? You can't really area model 3 dimensions. It doesn't work like that, right? So we use Pascal's triangle and this theorem to work it out. So here's what we first have to do. We first have to identify what exponent we are, and then we're going to apply that to the level. So on Pascal's triangle, the 1 at the very top is level 0, meaning the exponent of 0. The next level is level 1, and then 2, like I had mentioned with 1, 2, 1. And 3 is what I'm actually looking for. So the 3 is going to be a 1, a 3, a 3, and a 1. Now again, those are coefficients. So let's get started. Our first value we would call A, and our second value we would call B. But in this case, we're just going to use x and 5. So our first term's coefficient is going to be 1 times the x value to the highest exponent that's there, which is 3. And then we're going to multiply that by the next value in the binomial, which is 5. But we start at the lowest exponent that's there, which is 0. Now we don't see the 0, but it's clearly there. We're going to follow this process throughout for the remainder of our coefficients. So our first coefficient was 1. That's where that 1 goes. So our first value or our first term in this final product is going to be the result of doing this calculation. I know, it's a lot. Plus signs are in the middle, which are good. Plus. The next coefficient is 3 times x, but I'm going to take away one exponent because we're going to go downhill on the first value's exponents and uphill on the second value's exponents, times 5 to the first. So see what's happening here. X to the third, then we go to x to the second power. 5 to the 0, then 5 to the first. And we're going to continue that process. One's going downhill while one's going uphill. Plus, the next coefficient is also 3, times x to the first power. So again, here we have a 3, a 2, and a 1, times 5, 0, 1, 2. And we're almost there. Plus 1 times x to the 0 power, which will eventually cancel out, and then times 5 to the third power. And now we can finally go ahead and simplify, but let's just take a quick look and see what we did. 1, 3, 3, 1. 1, 3, 3, 1. X to the third, x squared, x to the first, x 0. Downhill on the first ones. 5 to the 0, 5 to the first, 5 squared, 5 to the third. Uphill on the second ones. So let's put this all together. 1 times x to the third is x to the third, and 5 to the 0 power is just 1. So our first term is going to just end up being x to the third power. Plus 3 times x squared is 3x squared times 5. So this is 3 times x squared times 5, which is going to give me 15x squared. Okay? Plus 3 times x to the first times 5 squared. Well, 5 squared is 25, and 25 times 3 is 75. 75x. We don't have to put the first power because we're there. Finally, 1 times x to the 0 power, which is just 1. Anything to the 0 power is 1. And 5 to the third. You'll need a calculator, right? So that's going to be 1 times 125, which is just 125. And this is my final answer. My final answer is x to the third plus 15x squared plus 75x plus 125. And there we have our first answer. Whew. Let's go with number 2. I'm going to go with a different color, though. Okay. So now we have a fourth power. So we're going to go down one more level because we're going to end up with 5 terms here, right? So the fourth value is 1, 4, 6, 4, 1. So let's get it going. 1 times, what's the letter again? I can't, it's so much on the board. A to the highest power times 2, or negative 2, to the lowest power. So the negative is going to be important here, right? Plus, so the negative will always go with the sign or with the value. 4 times a to the third times negative, you okay, buddy? Times negative 2 to the first power plus 6 times a squared times negative 2 to the second power plus 4 times a to the first times negative 2 to the third power plus 1 times a to the 0, I'm going to run out of space, times negative 2 to the fourth power. Okay, now the negative signs are going to take care of themselves, right? Because eventually we're going to have some negative terms here. So let's go ahead and work it out. 1 times a to the fourth is just a to the fourth, and anything to the 0 power is just 1. So there's no negative here. This is just a to the fourth power. Now, I'm not going to put the plus or minus yet because we might have a negative somewhere. 4 times a to the third is 4a to the third times negative 2 to the first, which is negative 2. So this is going to end up being negative 8a to the third power. Okay. Here, 6a squared is just 6a squared, or 6 times a squared. Now, negative 2 to the second power is positive 4. So this is going to be 6 times 4, which is 24a squared. So positive 24a squared. Here, 4 times a to the first is just 4a. But negative 2 to the third power is negative 8. So this is negative 8 times 4a, which is negative 32a. And then finally, 1 times, again, a to the 0 power is just 1. And negative 2 to the fourth power is 16, yes? Okay, so we're going to have just 16 because the a cancels. Our final answer is a to the fourth minus 8a to the third plus 24a minus 32a plus 16. Let's do 2 more together. Example 3, we got a fifth power, so we're going to have to go 1 more level down. So the fifth power is right here, where we're going to have a 1, 5, 10, 10, 5, and 1. So there's going to be 6 terms here, so let's get it started. So this is 1 times u to the fifth power times negative 3 to the 0 power plus 5 times u to the fourth power, right, 1 level down, times negative 3 to the first power, 1 level up, times, or I'm sorry, plus 10 times u to the third power times negative 3 to the second power plus 10 times u squared times negative 3 to the third. Take your time. It's going to be really important that you do that. Plus 5 times u to the first power times negative 3 to the fourth times, plus 1 times u to the 0 power times negative 3 to the fifth. And goodness gracious! Titan! Okay, sorry. Oh, hey, I'm sorry. I thought he was downstairs. He just ran in here. He's like, what? What, Dad? What do you want? Huh? Okay, let's clean this up. 1 times u to the fifth is u to the fifth times negative 3 to the 0 is just 1, so this is just u to the fifth. And I won't do the plus yet. 5 times u to the fourth is 5 u to the fourth times negative 3, which is negative 15 u to the fourth. Negative 3 squared is 9, so 9 times 10 is 90. 90 u to the third. Negative 3 to the third power is 27, negative 27. And negative 27 times 10, gosh, negative 270 u squared. Help! Send help! Okay. Negative 3 to the fourth power, 81 times 5. Good things, these are easy numbers to multiply by. 405. So 405u. No, 405u. Huh? And then we have a negative 3 to the fifth power, which I don't know. I think it's 243. Yeah. Negative 243 is what this ends up being. Whew, send help. All right, so our final answer. U to the fifth minus 15u to the fourth plus 90u to the third plus, or minus 270u squared plus 405u minus 243. Gosh! Okay. Fourth one's a little different because now instead of 1 term, I've got 2 in the front. It doesn't matter. Now let's work it out. Now it's only a third power, so let's see if we can get this right. You can go ahead and try it, but I'm still going to work it out without having to go too deep with it. So it's a third power, so we need level 3. So I'm looking at a 1, 3, 3, 1. So let's try this. 1 times 5y to the third minus 1 to the 0 power. Okay. Plus 3 times 5y squared. My brain actually went really slow for a second. Do you see that? It's very strange. 5y squared minus 1 to the first power plus 3 times 5y to the first power minus 1 to the second power plus 1 times 5y to the 0 power minus 1 to the third power. All right, this is going to be a little weird, so let's go ahead and clean it up the best we can. 1 times 5y to the third is just 5y to the third minus 1 to the 0 power, which is 1, which is going to be, okay, now this is where it gets a little tricky. That 3 actually distributes to both things here. That 2 distributes to both things here. That 1 and that 0. So we're going to be distributing within there. So the 3 actually goes to the 5 and to the y, right? So here's what's going to happen. This really says 5 to the third times y to the third. This says 5 squared times y squared. Just when you thought it couldn't get any worse. 5 to the first times y to the first. 5 to the 0 times y to the 0. Okay, so it's within itself, right? So 5 to the third is 125. Y to the third. Everything else cancels. 5 squared is 25. Times 3 is 75. But that's a negative 1. So this is going to be negative 75y squared. 3 times 5, because 5 to the first is 5, is 15 15y. And then the last one, 1, 1, 1, negative 1. Done. Wow. On the good side, you probably won't have a lot of these to do in one setting, right? Your teacher probably will only give you like maybe 3 or 4 maximum like we did here, but in a more controlled setting because this, like you can't even see me right now because there's so much stuff going on. Let's finish up. Things to remember about this video. Number 1, binomial theorem is how we expand binomials with higher powers. Clearly, I could have just multiplied a power of 2 by foiling or by using the area model, but this really helps us with the identification of what happens when there's a 4th, 5th, and sometimes we can get even a 6th or 7th power. Because Pascal's triangle is infinite, it just keeps going. More on that later. Number 2, the triangle itself helps us identify only the coefficients of what these numbers are. Really and truly, we could certainly multiply it out, but without knowing what the coefficient is, we won't know what the end result's going to be. So knowing what the coefficients are really do help us in the long run. And then number 3, I even said this during the process, just take your time. When you take your time and do one step at a time, you minimize the possibility of mistakes, and you can go a lot farther and just get the right answer and be done with it. Because I don't want to do these things more than once. You probably don't either. See you next time.